Hi everyone, and welcome at Keep Calm and Secure CI/CD pipeline. So I'm Sonya, I work dark hoodies, so I'm a legit security engineer, obviously. So I want to start to introduce what is cybersecurity and why is it important. So cybersecurity is the techniques of protecting computers, networks, programs, and data from unauthorized access and attacks that are aimed for exploitation. You might have remembered in 2016, there was a series of DDoS attacks that disrupted a lot of web services, including GitHub, PayPal, Twitter, and you could see something like that at GitHub, the pink unicorn. So are some of you familiar with Shodan? Cool. So for those who don't know, Shodan is like the Google of IoT. So in that case, I've put, it's quite small, but I've put webcam in the search field. And this is what I could get. It's like open, just directly connected to the internet. Obviously, I redacted the IP webcam. But what happened during DDoS? So basically, the attacker will go to this website and harvest bots, because they're using default credential, and then launch an attack against servers and exhaust the resources. Another example for cybersecurity attacks are ransomware. So this was for the WannaCry ransomware. So usually an attacker will, this is just one scenario, will send a phishing email, and the user will click on the email, and on the background, the malware will be downloaded, and it will encrypt the data. And usually the attacker wants you to pay Bitcoin. So this is the consequence of the WannaCry ransomware. 130 countries were hit. That's another example of cybersecurity attacks. This is sextortion. So basically, you can see the little blur at the top. That's the password. And the attacker will tell you, I've put a malware on your machine, and I can record everything you're doing, all the naughty things you're doing. So if you don't want me to send it to your family, pay that Bitcoin at that Bitcoin address. Also, what happened, Ashley Madison were a victim of a data breach, and now there's a second piece on that one. It's actually attacker taking advantage of that data breach to say, oh, I've actually got your profile from Ashley Madison, and you should actually pay some Bitcoin, otherwise I'll just tell your family. So what I would recommend is, obviously it's a scam, but you can take this Bitcoin address and just have a look at the wallet, and you would see that it's actually a scam, because no one is sending money to those wallets. Also a good way to see if one of your email address has been breached, you can use a website like Have I Been Pwned. Obviously, instead of I Love Cook on London, you put your email or your email address, and you would see where your account has been compromised. So this is just an example of some of the companies that had a data breach. So you can see like almost all the companies that we know had one. Also, this is just, if you love analytics, this is another view of all those data breaches. So how data breaches occur? So usually an attacker will either do a little bit of social engineering to get information, or they will look for weaknesses in the infrastructure. Once they find a weakness, they will infiltrate the network or your application, exfiltrate the data, and then dump it where they can sell it, because data is something that they can sell. So let's have some examples on web app attacks. So the first one is on the Donald Trump website. So the Trump cop did something stupid. So one of their developers actually embedded a piece of code on their website. This was the piece of code that the developer embedded. So this tag was in the source code, so if you look at the source code, you could see that. And it was pulling directly from a developer called Igor Escobar. That's Igor Escobar. So basically, with open source, you can submit a PR and inject arbitrary JavaScript code into Donald Trump's website. In that case, this was the website. If you were checking the source code, you could actually see the script. So if the file on GitHub gets modified, it will get reflected within 30 seconds on the website. So the repository was around enhancing the UX of submitting a form. So this is the JS Mask plugin. So as I said, if anyone submits a PR, then it will inject on the Trump's website. So what you could do, you could actually modify the DOM, you can challenge the visitor to install software, you can redirect them. So what if you would actually redirect the user to Clinton's website? So let's see. So if you open your DevTools, obviously it's not going to reflect, but you can do the tests on Trump's website and put this little piece of code, and obviously it will redirect to Hillary Clinton's website. Boom. And what if actually you put it, edit on and raise a PR? So the researcher actually demoed this. Obviously, he didn't raise the PR, but this is how easy it is actually to raise a PR on the open source. So the good news is the security hole has been fixed around less than 3 hours. It was just bad publicity for the Trump campaign. Another attack is, and I'm sure you might have heard of some of them, is crypto miner incidents. So this one has been on several websites, including the ICO, United States courts, General Medical Council, Manchester City Council, or also in Australia. So basically, more than 4,000 websites were hit by this attack. And actually, it wasn't the website themselves. It was a script that they were embedding on their source code. So the script that has been tampered is from TextHelp. So that's TextHelp. They're doing assistive technology, which is good. It's for accessibility. And one of their products is called BrowserLab. That was the one that was actually tampered. So you could say it's like a 1, 2, 3 step. You just copy-paste the script and you put it within your code base. And now we're back to the Trump scenario, and it's real in that case. So let's take this one, the BA.js. You could see the obfuscated bit at the top, which is actually the crypto miner. And then, so what happened? So basically, the attacker managed to get access to where they were actually storing that file. The file gets distributed from their CDN, and now every single website has the crypto miner embedded in their website. Obviously, there's an impact for the user because it's slowing down the process. Another example is how to social engineer developers. So this one is interesting. So I don't know if you heard about that story in 2018. There was a package called FlatMap stream within the event stream package. So basically, that package has been that malicious package has been downloaded 8 billion times. So you can imagine a lot of web applications had it. So the event stream is basically a toolkit for the JavaScript to create and manage streams. It was authored by Dominic Tarr. So this is Dominic Tarr. So basically, when they started working on this package, so one of the user, Devious, asked if a flat map functionality would be welcome. And you could see actually at the end of the issue, Dominic Tarr saying, if you publish a flat map module and then make a PR, I will merge it. So this is actually a good sign for the attacker. So one developer actually created this package in 2018. And then the attacker, which is called Right9 Control, approached Dominic and say, let me do it. I will just merge the fixes. Don't bother with this. So Dominic trusted Right9 Control and gave him full access to the NPM registry. So you could see that at first, Right9 Control just pushed cosmetic changes just to build up the trust, and then he pushed the malicious code. So obviously, after the malicious code was pushed, a lot of users raised issues, saying there was some slowdown on Nodemon and other dependencies. So people started seeing that something was going on. The target was a Bitcoin wallet. So that's the target, COPAY. Now the website is down. It has been retired. So the strategy from the attackers was to wait for the right opportunity to be built within the COPAY app. They've actually succeeded within this range of version. So since that incident, the repository for event stream has been archived, as you can see at the top. Right9 Control profile on GitHub has been pulled down. And this is usually the type of message that you could see for people that has to upgrade their packages. Another quick one, what else can go wrong when you push credentials on GitHub? So GitHub is housing thousands of publicly accessible keys, token, passwords. You can just do a quick search with, for example, API keys, and you'll see those loads appearing in the search. And you can see that's just an example of API keys. And when developer realize that they pushed the keys, they try to change it, but obviously it's too late because it's version control, so they will remove with X's, or they will just delete, or they will just put empty strings, but still the issue is the same. The API keys are still on GitHub. So you could find keys for all of those services, so that's great. So example with Google Maps, with Stripe, production. So yeah, great findings. So let's go back to what is web application security. So web app security is a branch of InfoSec that deals specifically with security of websites, web apps, and web services. You could also implement web app security within the software development lifecycle. So the software development lifecycle is just a framework that defines from start to end the process used by the organization to build an application. So this is usually the step that you can follow, coming from planning. You have the requirements, you prototype and design the product, then you implement the code, you test, and then you deploy and you maintain it. But you can actually inject security at each of those steps. Should it be penetration testing, code review, threat modeling sessions, architecture analysis. And if you do this, security is a continuous concern. Awareness of security consideration are also by all the stakeholders. And there's an early detection of flows, and obviously there's a cost reduction because you don't want to fix the issues at the end of the pipeline. So how do I get started? I guess OWASP is a good start. So OWASP, who here is familiar with OWASP? Cool. So OWASP stands for Open Web Application Security Project. They do have a new website that they've pushed recently. And they also release a lot of documentation around not only application, but mobile, IoT, API, and everything is free. So some of the most well-known is the OWASP Top 10 and the OWASP Proactive Controls. So the OWASP Proactive Controls is a list of security techniques that should be included in every software development project. So this is the list of the top 10 proactive controls. The first one is, as we said, define security requirements. And to help you, you can use another OWASP documentation called Application Security Verification Standards, which has also a checklist that'll check against authentication, session, API, and all of those. You might be familiar with user stories, but why not also using abuse cases? So this could be an example of an abuse case. So if you're working on a broken auth feature, you can have, like, as an attacker, I have access to hundreds of millions of valid username. Obviously, you don't want this in your application. So you can work around those abuse cases. Another one is to leverage security frameworks and libraries. So basically, you don't need to reinvent the wheel. Better use secure coding libraries and software frameworks. So a good tip usually when you use those packages is to see how many contributors they have, how many commits, when they last push on it. Also, for example, for the JavaScript ecosystem on the NPM registry, how many weekly downloads to see if actually it's a popular package. The other well-known OWASP is the top 10. So they usually release one every 4 or 5 years. That's the latest one. 2017, and we're going to focus on the A9 using components to win known vulnerabilities. So how do you know if your application is vulnerable? Who here knows all the versions of all their components? I'm not talking about the main one like React or, yeah. So if you don't know the version of all your components, should it be client-side or server-side? So your application can be vulnerable if you don't scan for your vulnerabilities, and if you don't fix or upgrade your vulnerabilities. So how can you prevent it? I will give a list of tools to actually help and support on that. So one obvious thing can be to remove the unused dependencies, just to do a little bit of inventory for both client-side and server-side. I'll give some tools that will actually give this, because obviously you don't want to manually do the inventory. Also, a good one is to obtain components from official sources. Be careful when you install a dependency to avoid typos. So for example, if you do an npm install React, don't put like 2e, it might be a malicious package, who knows. So I'd like to present the Prime London open source project. I'll show you the different tools that we're using within GitHub. So disclaimer, the perfect CI/CD pipeline doesn't exist, sorry. So Prime London is an open source project with around 20 developers. We're doing the website and the app. And we're using all of those tools and platform. So we're also using those tools from the GitHub Marketplace, because they're usually free for open source, which is good. So this is just an example with the security tools, or you can have a play with it. And as you can see, we've actually tried a lot and decommissioned a lot. I'll go on why the challenges that we've faced on with some of them. And also another example of all the GitHub apps that we've been using. And usually what I would recommend when you work on the open source is just to give access to only selected repos and not just give access to all the repos. So we're using Gatsby to code in React. We're using TypeScript. That's the framework they're using for coding. We're fetching the info from the information, the data from Contentful, which is our CMS, through GraphQL queries. So this is just an example of where we put our content model, content, and we just built our scheme on that on Contentful. So where we fetch the data. And we have a lot of webhooks to have that automation through Circle CI, Gatsby Cloud, Slack, Netlify, all of those. And yeah, this is just an example of one of the webhooks. So usually when you publish or unpublish, it will trigger those webhooks. And you have also audit logs for those. We're using Gatsby Cloud for the build time. So usually for every PR branches, it will just build your website and give you, it's actually quite detailed on the steps that they're following. So if you're curious about to know what's going on behind the scene, Gatsby Cloud is quite thorough on that. We're hosting on Netlify. So same, we have production deploys and preview deploys on it. There's also thorough logs around it. So for the continuous integration, we're using Circle CI. So basically, for each time you push in code for a PR or a commit, it will trigger a Circle CI build. We've reached around, for an open source project, almost 9,000 builds, which is quite amazing. So we have a couple of steps for our Circle CI scripts. This is just to give you an idea around the dependency, if it's safe or not. It has to fetch it, running the linter, and running the tests. We're using CodeCub for the code quality. So all of those tools are free for open source projects, so you can actually use all of them. So it's the same. It will go through each of the PR and commits and calculate the delta and let you know if there's an increase or decrease on the coverage of your code for the tests. And it will actually inject it through the PR on GitHub, so you could have this visualization, which is quite neat on your PR page. And obviously, you can run all of your tests. They also have an HTML format, so if you don't find it easy to navigate or read, you can just use this HTML web page. We're using Codacy for the code quality. So actually, we used to use Codacy so first of all, as you can see, there's like a drop. So I've actually turned on all the rules on Codacy and tried to fine-tune regarding for our projects. And then you can see it became flat. But as we're actually moving to TypeScript, it became this sort of hybrid application that Codacy couldn't actually cover properly. So it was giving us a lot of false positive. So we actually had to decommission the tool at the moment. Might probably come back to this tool after when we have the whole code base in TypeScript, but for now it doesn't make sense. So we're using another tool called Code Factor, which is doing basically the same, going through the PR and the commit and let you know if there's any things that you can improve around code quality. They will also give you some remediations and advice on how to write like proper code quality code. Another good one specifically for JavaScript and TypeScript is DeepScan. So also the same, go through PRs and commits and let you know if there's any improvement that you can have. The good thing is quite thorough, so I will actually tell you exactly where it is. It's not just the block of line, and the explanations are quite good on that one, so quite happy. LGTM is one tool that has been both acquired by GitHub recently, so also free for open source. Same principle, going through the PR and your commit, it will give you delta. Really thorough also explanations around that. They will also link to the official documentation. So in that case, because we're doing a React project, so at the bottom you can see a link to actually the bit that you can improve. In that case, it was state and lifecycle for React. And you can also compare against other open source projects to see how good you're doing or how bad you're doing. Another one, quick one, just that's funny, is just to size your pull requests. It will actually give you, put the little label when you raise the PR if it's a small or a large or XL. For compliance, we're using the tree. So what is good with this tool, because usually for open source, those are some areas that you might probably skip around having code owners, ensuring that you have a proper git ignore file, that you're doing a little bit of cleanup with leavers and new joiners within your project, that you're not pushing keys within your code base. So we'll flag all of those. So if it's not compliant, it will be red, actually. Another one for security tools that we're using is guardrails. So this one will actually scan your code base and let you know if there's any API tokens or credentials that you might accidentally have pushed on your code base. So the same, it will just scan every PR and every commit and let you know if there's something that you can fix. For the packages, we are using several tools. So Sonatype is, DepShield is one of them. Sonatype is raising issues. It's quite thorough and quite, for some who are not used for, with security, can be quite overwhelming sometimes because they're checking against CVSS score. So if you're not familiar, you can have just a view on how they calculate the score for the vulnerability. I would recommend using Dependabot. And Snyk, obviously, I'll come back to Snyk. Dependabot has been acquired by GitHub, so it's natively integrated. So that's pretty good. And you can either configure it through their online platform, or you can use a config YAML file if you want to target specific branches or specific languages, all of those. So Dependabot will raise automatically a PR. Telling you to which version you need to bump your version. If you have an integration with Slack, it will actually feed through Slack. And the good thing is what they call the compatibility score, which so basically they will compare against other open source projects, and they will increase or decrease this score if it doesn't break their pipeline. So it gives you a little bit more confidence. So to have Dependabot on GitHub, you actually need to enable dependency graph. So dependency graph will allow you to actually scan those dependency package file and let you know if there's any vulnerable packages. So it's not only for JavaScript, they actually cover a lot more languages. If you want to enable, because it's basically enabled by default on public repos, if you want to enable it on private repos, you need to go to your repo inside dependency graph and allow access. And then you can use Dependabot after that. Yeah, also GitHub will send you regular emails depending on your settings, but you have like security alert digest when there's any vulnerability that you have in your code base. Obviously, there's also Snyk, which is free for open source, also a really good tool for scanning your third-party dependencies. They do have an online platform. Well, they will let you know what is, when they have a vulnerability, what is wrong with, and how we can remediate with this vulnerability. There's Slack integration as well. So you can fix also through the CLI. They have a CLI wizard. They can help you create those Snyk policy to improve your the vulnerability, your packages. For those who are wondering how does it work, it works actually through webhooks. So with Slack, you can do integration through webhooks. So usually those platforms, they have those one-step integration with Slack, and you just have to put the URL so you link your the tool with Slack, and then you can start actually feeding specific channel around that. And also, obviously, they will send you emails to let you know if there's any vulnerability. For monitoring, this is specific for JavaScript. I think there's other also languages, but once your website is live, it's also good to see what kind of errors we could get. So Rollbar is taking like top 10, top 5 errors and let you know with graphs what are the most common errors that you could get on your website, and you don't have to go to the DevTools to check against it. So how does it work on GitHub? Because I've shown you a lot of tools, and you might wonder, how does it show on GitHub? So basically, when you raise a PR, as you can see, the code cov actually is integrated within the PR. But if you scroll at the bottom, you will see all of those checks. So it's like a pipeline with all your tools. And you also have the other tab called checks. This will depend on the tools. If it's natively integrated through GitHub, you'll have also more information around that tool. So just to give you an idea for the compliance, for LGTM, for code factor, they'll give you more information. So you don't need to go on their platform. Everything is centralized on GitHub. What we've done at Prime London is have specific Slack channel where we could actually feed all of those results. So when we have some deployment from Circle CI or deployment on Netlify, when we have results from Rollbar or Guardrails or Sneak, we have specific channels for each of them. And obviously we have the tech GitHub, which is the one that actually feeds all of the steps. As you can see, actually in real time will let you know if there's one failing or in process. So it's quite good. Like you can stay in Slack and have this monitoring and follow your process. And obviously, because it's open source, so all of those platforms have those little tags and badges that you can actually put in your README file. And I guess it's also good when you're doing open source to just showcase that your code is having some sort of standards, and people can come and contribute to that. So we've been also using the GitHub board. So we've tried to implement the Jira methodology on the, whoop, oh, what happened? Sorry about that. Cool. So we've been implementing all of those labels around epics and categories. So as you could see, we have like different epics, the same as you could find on Trello or Jira. So we'd work through epics, through stories, and we're using what they call the automated Kanban. So it's linked with your PRs. So once you raise a PR, it will actually move automatically on the column. So when it's in code review and when you merge and close, it'll automatically actually move through the column. It's quite cool to see it. And also, it's also a good way if you want to have a proper project when you're doing open source for the different maintainers that you have. You can assign tasks and have like the proper project management that you'd find with Jira or Trello. Also, in terms of security, basic hygiene on GitHub. So by default, for Prime London, we require 2FA for all of the developer, because it doesn't matter if it's open source and if they're maintainers, they have to have 2FA enabled. All of the base permissions are none. So we've created separate teams, and then the maintainer will be affected to one of the team. And then they will have read or write access depending on which project they're working. All of the master branch has been protected, obviously, because we don't want people to be able to delete the branch. We also have 2 or 3 reviewers per PR, and because we've added all of these tools, we're making all of these tools record and make the build fail. So I wanted also to introduce you to a feature that could actually prevent the cases that I've introduced earlier with Trump and the crypto miner. Who here is familiar with the content security policy? Cool. So CSP is it's actually a header that acts as an added layer of security that will help you mitigate injections of the type like cross-site scripting. So basically, you could actually whitelist assets per page. If it's not on this list, the browser won't load it. So you have very good documentation around the CSP from Mozilla. There's also, if you don't know, the contentsecuritypolicy.org, they have a specific website where they actually give you the list of directive and the value that you can assign to it, because obviously there's different type of assets that you can implement within your website. Should it be images, fonts, media, scripts, frame, and you would have all of the values. And they will also give you example of CSP. So usually what I would recommend is not to integrate the CSP straight on the way. It's just to probably turn on the report only at first so you can have time to fine-tune your CSP because you will get a lot of errors. And you can use report URI to actually digest those errors and fine-tune your CSP, and then when you're confident, you can push it live. Who here is familiar with sub-resource integrity? Okay, less. So usually when we talk about CSP, we also talk about sub-resource integrity. So that's another security feature that enables the browser to verify if a resource hasn't been tampered when it's fetched. So basically, when you're fetching, when you're copying the script, should it be jQuery, Bootstrap, or any script that you're using, they have this, that option with the SRI. So basically, the SRI would be this integrity checksum that you have at the end, and then it will prove it's coming from an official source and it hasn't been tampered. And if you are using script, or if your company is producing script, you can actually generate this SRI and just append it to your own script. It's basically, I guess, like covered by most of the recent browsers. Also good documentation on Mozilla on that. Whoop. Okay, and just to finish on more tools, security tools that you could use, or just to improve the quality or the performance of your website that we're also using at Prime London. Who here is familiar with WebHint? It was called Sonarwell before. Okay, a few. So basically, you will just put the URL of your website, and it will scan your website and tell you areas where you can improve. So should it be accessibility, progressive web app, not only security, but you can improve on different areas on your website. The good thing is the explanation are quite thorough, and they will give you remediation on that. It's free as well, so it's good. Obviously, I think you might also know Lighthouse from Google. So basically, how you can trigger a scan, you just open the dev console, you go to the audit tab, and you can launch a scan. Should it be on mobile or desktop or one of those categories, and it will give you also areas where you can improve. Another one, PageSpeed Insight. This is more on the performance side. Another one called AppStrand. Also, they can give you diagrams and visualization of where you can improve for your website. In terms of security, there's a good one like Qualys around certificates, if you're not sure for your open source project, and also security headers, if you want to check the headers that you've actually implemented within your projects. So some key takeaways on that. As you've seen, open source can be a vector for large-scale cyber attacks. As I showed with the Trump and the crypto miner, you could see actually the impact on 4,000 websites or 8 million applications. The good thing is, if you're hosting on GitHub, you can leverage the applications that are available on the GitHub Marketplace. You can also start creating a small pipeline. Obviously, you don't have to use all of those tools to make sure that you have a good pipeline. And you can start also harden your GitHub security around 2FA, around creating teams and allocating your maintainers to those teams for your capabilities. Experiment, because all of those tools are free for open source, so it's just experiments. For Prime London, we've experimented a lot of them. We've decommissioned also quite a few because it wasn't just, for example, for courtesy, because we've moved to TypeScript, it didn't do the job, so we had to move to another tool, but we might come back to those tools later on. Also, one, don't push your keys on GitHub. That's an obvious one. For the resources that I've used, a good read, I would recommend the State of Open Source Security report from Snyk. Also the blog posts from the Snyk website. They're doing really amazing pieces, and also around the event stream events. Another good one, the report from Sonatype, also around the software supply chain. And Troy Hunt, who's an Australian security researcher, also writes a lot around CSP, SRI, and all of those tempered scripts. So good resource that you can have a look at. If you're interested in security, I wrote a piece on Medium where I gather like podcasts, YouTube resources, also run OWASP. So if you're interested in security, but you still want to stay in development, you can have a look. And also that's a call for any woman or someone identified as a woman working in cybersecurity. Just talk to me at the end. I can just add you on this list to promote diversity and inclusivity within the cybersecurity industry. And yeah, I will just finish with my motto. Get secure, be secure, and stay secure. Thank you.
Thank you. It was really a huge list of tools. Yeah, like we will definitely need slides and go through and click on all the things. So people, if you have questions, I ask you to go to this mic or this mic because the room is large and it will be complicated to run. So if you have a question, please approach the microphone. And while you're thinking, don't die, please.
Yeah, that's right.
Okay. Sure. That's okay. While you're thinking, I actually have a question.
Yes.
Do you use fuzzers, like fuzzing tests? Because like in our case, as we do a lot of cryptography, we really rely on those automated fuzzer tests, when just automated software that tries different input types of data, like random data. And do you use them as well?
Yeah, so I do some penetration testing on the website. I'm using tools like like OWASP, so just a fuzzing tool. So yeah, we do that exercise. It depends on the feature that we're delivering, but usually just to cover that security side, we do pen test.
Okay.
Yeah.
Okay.
Internally, in that, yeah.
Yeah. And do you have some nightly tests? Like, those, like, for example, long integration tests that you run like every night because they're too long?
So for now, we only have unit tests. We don't have the end-to-end integration test, but this is something that we want to go. Yeah, this is something that we want to explore. But for the time being, we only have unit tests.
Awesome. Okay, thank you. I see a question here.
Hello, thank you for your talk. In terms of web application security, do you think the wide adoption of WebAssembly poses a security challenge?
That's a good question.
Like, how do I audit, like, we have all this malicious JavaScript.
Yes.
How do I audit, like, the malicious WebAssembly now?
That's a good question. I guess probably, I don't know if at the moment on the market we have tools that might scan, so probably rely on that at first. Or we could also do code review, security code review on the code base.
Do you think we need something more for WebAssembly, or like the evolution of current tools and approaches should be enough?
I guess probably. Yeah, I guess it's the same as for any web app. You would also do some piece of education for the developers, so it's not only relying on the tool, but it's also having that piece of education. It's more like shifting left for them, so it's more around doing like threat modeling sessions or doing some code review or architecture design and see how they will implement the codes. So you have both the tools and the education.
Thank you. Any more questions? Yeah.
Hi, thank you for the session. Is there a tool for scanning the artifact that you already deploy when there is a new CV that came up after the pipeline is finished?
Yeah. I guess, yes. I think Sneak is doing it. After,
it's an asynchronous.
Yeah. Sorry?
It's an asynchronous, continuously check your dependency.
Yeah. So it will go through your package dependency file, and it will let you know if there's any new vulnerabilities. So that's continuously. Yeah.
Great. Thank you.
And I believe that Sneak is one of these companies, and like there are more like that, like White Source Software.
Yes.
And you can rely sometimes you can rely on GitHub itself that will send you all these alerts. So yeah, the industry of scanning the open source tools is already like going large, and we have a lot of things to choose from. More questions? No. Okay, let's say thank you.
Thank you.
Thank you.